Hello there, creators. Welcome to the last lesson on momentum and impulse. And today we are checking at elastic and inelastic collisions. Now, if that was Chinese to you before, rest assured by the time you finish this video, you would be the master of elastic and inelastic collisions. Right. So please bear with me and just relax and follow through what I'm saying here. Right. Okay. So now let us check what are elastic collisions. So elastic collisions, we're checking at elastic collisions. So elastic collisions are those type of collisions in which the total linear momentum and kinetic energy is conserved. So in this case, kinetic energy and momentum is conserved. So this topic goes hand in hand with the linear momentum or the conservation of linear momentum, right? So in this case, you must know that always in an elastic collision, kinetic energy and momentum energy is conserved. Now, what does that mean? That would mean that the kinetic or the total kinetic energy before collision is equals to the total kinetic energy after collision. So that's simply what elastic collision is. So in this case, it follows that, okay, the sum of the kinetic energy initially would be equals to the sum of the kinetic energy finally, right? So in this case, we are also looking at two events, before collision and after collision. So how do you prove? Usually it's those last questions when they ask you, okay, is this an elastic collision? Then you'd say maybe yes or no. Then they'd say prove that using a calculation. Like that calculation is you just calculating the sum of the kinetic energy initially and checking if is it equals to the sum of the kinetic energy final. And what is the formula for the sum of the kinetic energy? So it's the formula for kinetic energy to be exact. So you'd need to have two objects in that case. So the sum of the kinetic energy initially would be equals to 1 over 2. You put the mass of the first object, mv squared, that is initially, right? Plus 1 over 2, the sum of the mass of the second one, the velocity of the second one, and that is squared, right? All right. So another thing that you do, you then again calculate the sum of the final kinetic energy, right? Finally, then you also do the same thing again there. Then it said mv f, right? That would be squared plus 1 over 2 m 2v2 squared, and that would be finally. Then after you do these calculations now, if it's an elastic collision, you'd also see that the sum of the kinetic energy initially will be equals to the sum of the kinetic energy final. Right. So what are the key points to see that most of the time collisions are elastic? You'd see that when they combine or you'd see that the objects do not combine after collision or cannot combine after collision. Those are usually the signs for elastic collisions. And another sign, or what we know from elastic collisions, is that there is no energy being lost to the environment. Hence, that is why the energy is conserved, because there's no energy going out externally, right? Okay, so simply that is what an elastic collision is about. So what about inelastic collisions? So inelastic collisions is simply the opposite of elastic collisions. So that would follow that, okay, in this case, kinetic energy and momentum is not conserved, right? So we'd still use the same calculation, but you'd see that for inelastic collision, you'd see that the sum of the kinetic energy initially will not be equals to the sum of the kinetic energy finally, or after the collision, right? So most of people struggle with seeing that, okay, this is the initial part of the scenario, and this is the final part of the scenario. So please always make sure you use the collisions to separate those parts, right? So if there was something that happened before a collision, that would be the initial, and if there's something happening after a collision, that would be the final, right? So please make sure that you use that to separate these things, right? So I'll be doing some questions on this type of questions, so that they now are easier for you to understand, right? So this is just me explaining the concept of elastic and inelastic collision. So guys, I hope that this was useful and you now understand what elastic and inelastic collisions are all about, right? So please, if this was useful to you, please make sure you share it with other fellow matriculants or Matric 20K4, so that they also are in the chance of understanding these topics that they are finding them hard, right? So please make sure you also subscribe to our YouTube channel, right? Please make sure you also follow us on our TikTok, right? And all our social media platforms at tutorials, and others are tutorials, right? Please guys, enjoy. I hope that you guys enjoy these lessons, and please stay tuned for vertical projectile motion. Thank you.